that being said, we have been doing equations for the past 3 weeks. And so what we're doing today, exactly, again, as Yolanda said, we are consolidating everything that we've done. So in terms of what we need to know, there's a couple things. And as we go through these examples, we're going to discuss what we need to remember about equations. But, excuse me, but we're going to work through some examples to make sure that we are understanding. Guys, remember your hand should not be raised right now. I've put on the chat what to do if you can't hear anything, or if you're struggling with audio and there's different things that you need to be able to do. Remember, if you're struggling, please send a message. Please also don't ask me what sections we're doing. I've put the sections up that we have done. If you want to know what sections we have already completed, you can go on Watobe's website and you can find them there. If they're not on the website, then they're coming up. Okay, so that's how you can check what is heading our way. But I've explained to you and I've told you what's our next 2 sections are. And yeah, if you want to know anything else, check on the website if it has been done. If not, it's coming up. Alrighty, so if we look at this first equation, what we have here is 3x minus 1 equals 5, and we're solving for x. So remember, grade 8, the whole point or the whole goal of an equation is to get our x while variable term alone. Now, in order to do that, and I said this every single lesson, in order for us to do that, we have to be able to use inverse or opposite operations. Okay, so inverse means the same thing as opposite. It would help if I could spell opposite. And opposite or inverse operations basically means that if we want to solve for x, we need to do the opposite of what the original equation told us to do. So if we have a look here, the first thing that we see is that we have got a 3 being multiplied with an x. So we've got a coefficient, and we've got minus 1 being subtracted. So what that means is I need to deal with both the coefficient of 3 and the subtraction of 1 in order to get x alone. Now, the first thing that we always deal with is whatever's been added or subtracted. So the first thing I'm going to try and deal with or get rid of is this minus 1. And to do that, we use our inverse operations. So what that essentially means is I want to add 1 on both sides of my equation, because what that's going to do is it's going to cancel it out on the left, but bring it back on the right. The reason it cancels it out is because plus 1 minus 1 is 0. So that's how we get rid of that minus 1. And the inverse operation part comes in because now when it comes over the equal sign, we can see the sign has now changed. It's become positive. It was a minus 1. It's now a plus 1. Right, now we know that 5 plus 1 is 6. And once we have dealt with whatever's been added or subtracted, we can now deal with the coefficient. Now remember, guys, this coefficient is saying 3 times x. So back to our inverse or our opposite operations, we have to do the opposite. And so that means I need to divide by 3. What that's going to do is it's going to say 3 divided by 3, which is 1, which gets us that x by itself. But remember, whatever you do to one side of your equation, you have to do to the other side. So we also need to divide the right-hand side of 6 by 3. And so what we end up with is that x is equal to positive. So guys, really importantly, when you are solving an equation, those inverse operations are very, very important. Now, sometimes when you do it at school, it's a bit differently to the way I do it. Hopefully, if you've been listening to your teachers, you're still doing the math properly. It's just a case of it might look a bit different. That's fine. Remember, if your working out looks a bit different to mine, that's not the end of the world. You need to be checking that you get the same answer as me. There's only one answer option. So you need to be checking that you do have the same answer as me, but your working out can look slightly different depending on how you've learned to do it. In this case, this is pretty much it, but there are some instances where your working out might look a bit differently. So I'm just telling you this so that you don't have to ask me, ma'am, I've done it this way, is it right? You're really not sure, obviously put it on the chat and we'll help you, but sometimes it does look a little bit different. Okay, so that's sort of a basic type equation. Like we should all be able to do that. Remember, if you can't, it's also okay. Go back and watch the videos, especially of lessons 1 and 2 a little bit, and you will be able to go back and do these really nicely. So let's have a look at question 2. I'll make this smaller in a second for you to screenshot. But if we have a look at question 2, what we've now been given is a situation where we have got an x term on both sides and a constant term on both sides. So what I mean by that is if we have a look at our actual equation, I can see that I've got a negative 11x on the left and a minus 4x on the right. And I've also got a plus 1 on the left and a 3 on the right. I also can see I've got some random minus sign in there. Let's just get rid of that. But basically the point I'm trying to make is that you have got an x on both sides and a number on both sides. And we don't really want that. What we want to try and do in a situation like this is we essentially are grouping our like terms. So what that looks like is we want to get all the x terms to the same side of the equation and all the constants to the same side of the equation, and that will allow us to solve. Sorry guys, got a frog in my throat. So what that essentially looks like is this negative 4x, I want to join this negative 11x. Okay, they are like terms. We want them to be on the same side of the equal sign as each other. And this is now again where my inverse operations are important. But minus 11 and x stays exactly as it is because I haven't done anything with it. But this minus 4x, because I'm changing its position in the equation, I'm taking it to the left-hand side. The inverse operation of minus is plus. So it becomes plus 4x. Now, in a very similar way, I want this positive 1 to join the 3. And so once again, my inverse operations need to apply. The 3 stays on the right-hand side. I didn't do anything with that. But now that we have got the positive 1 joining the 3, inverse operations tells me that I have got minus 1 now on the right. And now what you guys can see, hopefully, is that all of my like terms are together. I can see that all of my x terms are here, whoopsie, on the left-hand side, all of my constants on the right-hand side. And this allows me to solve my equation. So now we go and subtract or add our like terms. So negative 11x plus 4x. Remember, guys, if you struggle with this, A, you've got a calculator, but B, also just draw a little number line for yourself. And hopefully that will help you be able to add or subtract your values that you have. Hopefully I do my number line correctly this time. Okay, I'm adding 4. So here I am at negative 11. I'm adding 4. So I'm moving up my number line towards positive infinity. 1, 2, 3, 4. That takes me to negative 7. So I've got a negative 7x is equal to, and we know that 3 minus 1 is 2. Now remember, grade 8s, I've said this to you before, a fraction is fine. There's nothing wrong with a fraction. We don't really like fractions, but there's nothing wrong with them when it comes to an answer. So we do exactly the same thing as normal. We are going to divide both sides by negative 7 because we want to get rid of what is being multiplied with the x. But if I do that on the left, I have to do that on the right-hand side. And so what I have is x is equal to, now we just need to be careful, a positive divided by a negative is a negative, and 2 divided by 7 is just 2 over 7. You could write it as a decimal if you wanted to. I would just leave it as a fraction personally, but as a decimal, if we round it off to 2 decimal places, it is negative 0.29. But again, I would actually just leave it as a fraction. That's the most accurate form of your answer because you aren't rounding off. And so leave it as a fraction rather. Don't introduce decimals unnecessarily. Leave your answer as a fraction. Just make sure it's simplified. Okay, so now that we've done 2 of sort of like the basic types of examples, I'm going to do that for you. Just take a screenshot. If anyone has a question or anything that they would like to ask, now's the time to raise your hand. I did see in the chat, Dejan asking me to do 2x minus 1. I don't really understand what that means. That's not an equation. So just try and clarify that for me and I can try and help you. Sambiso?
Hello, ma'am.
Hi.
Ma'am, for my the second part of the equation, where is 2 divided by -7? Mine, I took the one, no, the 3 and put it in the left hand side. So it was 3. So it was 1 minus 3, which was equal to -2. And -2 divided by 7, not
That's
positive 2.
That's fine. So remember, I said sometimes we do it a bit differently. That's absolutely fine. So how you've done it is perfect.
So you can put it to the left or to the right, but the answer will be the same.
Yes, exactly. So I always just put my x's on the left-hand side. That's just habit. You exactly as you've just said. You don't have to, as long as you get them to one side and you've used inverse operations, as you say, you get exactly the same answer. So it's perfect.
Thank you.
Okay, Sibulela. There should be a pop-up to unmute yourself. There we go. Sibulela, what's your question?
Don't have a question, ma'am.
Okay, so your hand is up. Why is it up? Okay, that's all right. So guys, just remember that we raise our hands when we have questions. Sorry, Sibulela, you can just ignore me. I'm just clicking things. We raise our hands when I ask you to, and remember we're doing that either for questions or answers. Alrighty, so I hope you've all taken your screenshots. Dejan, I haven't seen a message from you. So again, if you can just explain what it is that you would like me to do, I can try and help you. But right now I'm going to move on to the next question. Okay, guys, remember as you are doing the questions, if you're doing them with me as I'm doing it, that's obviously absolutely fine. But please make sure that if you've got the wrong answer, you are correcting your work or you're asking me where you went wrong. Okay, so if we have a look at question 3 here, what we now need to be careful of is the fact that we have got distribution. Okay, now really, really importantly, whenever you've got distribution, so basically whenever there are brackets with a coefficient or a number or a value in front of them, we have to do it first, okay? We want to try and simplify the equation that we've been given to make it easier for us to go and solve for x. So we need to distribute first. Now, what that looks like, I don't know what happened there, but anyways, what that looks like is on this left-hand side of my equation, I can see I've got this bracket here, and that has a -2 being multiplied with it. So this -2 has to be multiplied with the 3 as well as the negative x. That is what distribution means. It means multiplication. On the right-hand side of my equation, I can see that I've got 9 times the bracket. And so what needs to happen here is that this +9 needs to be multiplied with the 2 as well as the x. All right, so that is the very first thing we do when we see brackets and when we see distribution. We need to deal with that first. Now, guys, remember I've said to you, and again, if you need to go and rewatch the videos, that's absolutely fine, but I have said to you to be very, very careful. This x right at the start of my question, that is a term by itself, okay? It is not being distributed. It's a separate term. So for now, we just leave it completely separate from my distribution. I will deal with it once I've distributed everything. But for now, that x is just going to stay there and we'll deal with it in a second. But I am going to do the distribution. So if we have a look at our first bracket, we've got -2 times +3. A negative times a positive is a negative, and 2 times 3 is 6. So I've got a -6 once I distribute that -2. Then I've got -2 times -x, and negative times a negative is a positive, and 2 times x is 2x. So what I'm doing, again, I'm distributing, I'm getting rid of those brackets, and I'm eventually going to solve for my x. On the right-hand side, I'm distributing again. +9 times +2 is +18. and positive 9 times positive x is positive 9x. Now that I've distributed, hopefully we can see that we have no more brackets. And so we can now continue to solve this equation. Grade 8, please remember that if you have questions, they need to go into the chat. I don't want to see any hands until I ask them. If you have questions on the chat, or you can send a message to Yolanda or myself and we will help you. Right, if we carry on with this, now you've got a couple options here, and this is why I've said your working out might look a bit different to mine, and that's fine. What I see on the left-hand side is that I've got x and I've got 2x. Now these, remember, are like terms. And so what that means is I could add them together just to simplify what I have on the left. Now you don't have to, but you can. So, excuse me. Right, so what we're going to do is I'm just going to quickly add the x and the 2x to get 3x. As you can see, what that does is that now instead of 3 terms on the left-hand side, I only have 2. So it just simplifies everything that I've got going on before I start solving my equation. So in answer to the question of, aren't I supposed to do inverse operations? I haven't started solving yet. I'm about to start solving, and so yes, I'm about to use inverse operations, but I haven't yet. All I did to get from 9 times the bracket is I distributed. There were no inverse operations involved yet. That only happens when I start solving, which I'm about to do. Okay, so those inverse operations. Again, it doesn't matter which side of the equation you group your terms. I always put my x's on the left, but it doesn't matter. You will get the same answer. So this positive 9x, I want to join the 3x. And in the same way, this negative 6, I want to join the 18. So this is where my inverse operations are coming in. That therefore means that I've got 3x minus 9x, again, because the 9x was on the right, it's now moving to the left. I need to use the opposite operation or inverse operation, is equal to 18 plus 6 because the negative 6 came over the equal sign to the right-hand side. 3x minus 9x, again, if you need a number line, that's cool. Otherwise, grab your calculator and that will help you. But if we just think about this 3x minus 9x, I'm subtracting a lot more than what I initially had. And so the likelihood is that I'm going to end up with a negative number. But again, draw your number line if you need. Here I am at 3. I'm subtracting, so I'm moving towards negative infinity. 1, 2, 3, 4, 5, 6, 7, 8, 9 takes me to negative 6x. On the right, 18 plus 6 is 24. What I now want to do is I want to get rid of that coefficient. Now remember, coefficient is being multiplied, so the inverse operation is to divide both sides by negative 6. And guys, we have to divide by negative 6 because I just want x. I don't want a negative x, I just want x. That leaves me with x on the left. Now, very importantly, again, a positive divided by a negative is a negative, and 24 divided by 6 is 4. And so we get an answer of x is equal to negative 4 here. So well done, everyone, putting that on the chat. Very nicely done. Okay, so for this question, what we needed to do was we needed to distribute first. So remember, when you were distributing, we're not doing inverse operations or opposite operations. That only comes when I actually start to solve my equation. Distribution has to happen first, and then I start to solve. So I'm going to leave that up there for you to take screenshots of. And if anyone has any questions, now is the time to raise your hand and ask me. Again, guys, remember, you can put questions on the chat as we're going through. But now is the time where you can raise your hands and ask me questions if you would like. Otherwise, we're going to have a look at another example. So if you don't have questions, you're taking screenshots and hopefully marking your work if you did it. Pretty. There should be a pop-up to unmute yourself. There we go.
How do you find the negative 4?
Okay, so the negative 4 has come from this step over here. 24 divided by a negative 6 gives me negative. So it was through dividing the 24 by negative 6. That makes sense? Pretty? Pretty, does that make sense to you?
Yes.
Okay, perfect. Lyndall?
Can I ask, ma'am, do you always ignore the one that is on our left hand side, the negative 6x or divided by negative 6?
What do you mean ignore? I haven't ignored anything.
We only look at the 24 divided by negative 6 and then put the answer below as x.
Yes. Yes,
Oh.
because remember what we've done is that dividing by negative 6, I have done that for a reason. So I've done that because in front of the x, I had a negative 6. I only want x. So I have to divide by negative 6. And then, like you say, whatever the answer is of that division, that becomes my answer.
Thank you, ma'am.
Cool. Okay. There was a question of if the x was behind the bracket of, would we still leave the x? Okay, so sorry, that just took a second for my brain to catch up. It would depend what it looked like. So the question was if we had an x after the bracket. So if we had the bracket 2 plus x, if the x was right next to the bracket, so there's no sign in between, what that would mean is that we would have to distribute the x in. However, if there was a plus or minus sign, so let's say it was the bracket minus x, then it is a separate term and we would leave it alone until we started solving our equation. So it very much depends on whether or not there's a sign in between the bracket and the x. Hope that answers your question. Amanda?
Ma'am, how did you end up getting the 18?
Okay, so the 18 came from the distribution right at the start. So if we just go here, panic. So that 18 came from me saying 9 times 2, and 9 times 2 gives me 18.
Okay, thank you, ma'am.
No problem. So it was just the distribution that I needed to do at the start. There was a question of where did we get the 3x? So very much similar. Well, not really, but it's basically simplification. The 3x came from me saying x plus 2x. So what I saw was that I had like terms on the left-hand side. And so I just added them together to get that 3x just to have less terms that I needed to work with. You don't have to, like you'll get exactly the same answer if you work with both terms. It's fine. I just decided to simplify. So you don't have to, you can, completely up to you. No cool? Nukutula, there's a pop-up to unmute yourself. Nukutula, there should be a pop-up that you can push to unmute yourself and then you can answer your question. Alrighty, put your question in the chat for me and then we can help you, okay? All right, so grade 8, you've done really nicely. I think it's time for a little brain break before we move on to our next couple examples. So, my brain break somewhere. There is one, I'm sure. Right. Okay, brain break. You guys know how this works. So remember what we're going to do here is you need to look at that equation and you need to solve it, basically. The first person who gets it right, remember you should be putting it on the chat. The first person who gets it right I will obviously say who you are, and then you can raise your hand and you can explain to us how you did it. So if you're a bit confused about what I'm talking about, that's also fine. This last equation over here, we need an answer to. There's a question mark there. I need an answer to it. So you need to look at everything you've been given in the first, the second, and the third sort of lines or steps, and you need to work out the value of the kite, the dice, and the chess piece so that you can tell me what the value of the last equation is. Okay, so give that a try. I'm gonna wait to see the right answer. I also indeed need to do it so that we can all be on the same page. So I wait in anticipation to see the right answer.
Sorry, I'm laughing because of the joke. Not because of anything. You guys stretch while trying to do the answer. So that's a good hint. But you remember, we are interested in seeing the last answer. Okay. And I'm just busy updating my WhatsApp status with this nice joke of mine to make my colleagues laugh and everyone else. I can't laugh alone to this joke. I can't laugh alone, guys. Kagiso, so the game is you need to find where the question mark is. You need to find that number. That's the game. You are more than welcome to put Lita, but I also laughed. I laughed a lot before I unmuted. So now I was just, commenting that I'm taking it into my status. Okay.
Sorry, I'm getting there incredibly slowly, but I am going to have an answer for us very soon.
Tinzolo, I'm not sure, Tinzolo, if that's your phone or what, but we really don't like spammers in this class. Okay, so I'm not quite sure if you can try and try to see if you can use your device nicely. Ooh, Teacher Sam already gave me an answer. I'm a bit cheating, guys.
Okay, so I haven't seen the
So I
right
already
answer
know
yet.
the final answer. Yeah.
Oh, sorry, guys.
Definitely is not 3,104. It's not 16. Let's keep going. Let's see who's the winner of today's brain break. Come on, guys. Woo! Lwazi got it. Yes. Lwazi, you can raise your hand and then explain to the whole class how you got it. How did you do it? Naledi, remember, I don't want any questions asking to any student except us. Remember that we are in a class and we're talking about maths only. So warning to you.
Okay, Lwazi, do you want to help us out here?
Yes, ma'am. For the first one, I said 16 plus 16 plus 16, and that is equals 48.
Perfect.
And for the second one, I said 8 plus 7 times 8, and that is 64. Then for the third one, I said 7 times 4 plus 4, and that's 32. And for the fourth one, I saw that the chess things are 8 double, so that means it's 8. So I said 8 plus 8 times 14, and that's 120.
Perfect, well done. And guys, really importantly, what Lwazi said there, look out for the doubles. So here we had 2 kites, which meant 1 kite was 8. If 2 is 16, 1 is 8. Exactly like what Lwazi said, we had 1 chess piece was 4, so 2 chess pieces is 8. And now what we also need to remember is BODMAS. So remember in the second and the fourth equations, what you need to remember is you need to be doing the multiplication first before you do any addition. So always remember BODMAS, but very nicely done, Lwazi, 120. I hope all of you that were a bit off had a look and saw how we did that, but that's essentially how we solve those equations. And guys, this is an equation. You're solving an equation. It's exactly what we've been doing for the last 3 weeks. It's just with pictures. Okay. But let's get back into some examples. Right, here we go. So the next example I want to look at is number 4. Now, I wasn't here when you guys did this. You did this with teacher Hugo, those of you that were there. So you have done this. Obviously, we are, your English, revising stuff. And there is a video if you need to go and revise it. But like I say, I wasn't here when you did this. So I'm going to just go through this question, but I'm fairly certain you guys are all okay. But obviously, ask questions if not. So here we've got 2x cubed is equal to 128. What I actually just want to do is I want to just move this down because this is very close to our last question. And so guys, what we need to bear in mind is that, it's absolute chaos, is we now have an exponent. Now that doesn't mean that we have weird things that we need to deal with or anything like that. It's still inverse operation. What we just need to remember is that an exponent comes with its own inverse operation that we need to solve. Now let's just remind ourselves, I'm solving for x here, so I want to get the x alone. That is what solving for x means. Please remember, any question should be on the chat at this point. So we have got a times 2 that we need to deal with, as well as a power of 3. In this situation, what we want to do first is we want to get rid of the coefficient. So if you were with me on Monday, I'm fairly certain I said this in this class, but you can correct me if I'm wrong. We almost do BODMAS in an opposite direction. So BODMAS usually tells me to deal with the exponent first, but when I'm dealing with equations, I'm going to go and deal with the coefficient first. So the first thing I'm going to do is I'm going to divide both sides by 2, because as we can see, what that automatically does for me is it gets rid of the number in front of the x, and now all I have left to deal with is the exponent of 3. Right? We have to divide the right-hand side by 2 as well, and so that gives me x cubed is equal to 64. Now, guys, there's lots of different ways that you can go about thinking about this. There's lots of different ways that we can deal with this. But essentially, again, we need to come back to inverse operations. So looking at this, whenever you've got something cubed, so any value cubed, I'm just using an x, but anything cubed, the inverse or the opposite operation of that is to cube root. It would be the same thing if you were squaring a value. So if we had a value squared, the inverse operation would be to square root. Okay, so now we have got a cubed. We want to get rid of that cubed. So what I need to do is the inverse operation, and so that is to cube root. What that does is the cube root cancels with the cube, leaving me with just the x. But remember, what I do to one side of my equation, I have to do to my other side. And so what I'm left with here is x is equal to the cube root of 64. Now, guys, just quickly, if you don't know where the cube root is on your calculator, I'm hoping we can all see this. My calculator is quite dirty, but just pretend it's fine. If you have a look above the square root button, you can see there's a little root with the 3 in front of it. That's a cube root. So what you're going to want to do is you're going to say shift, and then that button. It would help if I push shift here. Shift, cube root, there we go. And you get a cube root. And so now all you need to do is you need to type in 64 onto your calculator, and it gives you your answer of 4. Okay, some of you might just know what the cube root of 64 is off by heart, which is also absolutely fine. But either way, we get an x value of 4. So the takeaway from this example is the fact that when it comes to exponents, they also have inverse operations that we need to deal with or that we need to apply. Doesn't like the method that we're using to solve the equation isn't any different. We're using inverse operations. We just need to remember what those inverse operations are for equations where they are exponents. Okay, so just take a screenshot. If you have any questions on this, please raise your hand now. Otherwise, again, we're going to have a look at another example. But please raise your hand and ask if you have questions. And again, there is a whole lesson on this, and so you can go and rewatch it if you feel you need some revision. Pretty? What is your question? Again, you need to unmute yourself. There's a pop-up to unmute. Sorry. So you need to unmute yourself in order for us to answer your question. So there should be a pop-up. No, okay. All right, guys. So equations with exponents, nothing super hard, especially because you can use your calculator if you're not too sure what the cube root of a value is or the square root. But just remember what the inverse operation is. Alrighty. So, okay, apparently we're now back at number 1. We're not. We're obviously at number 5, but I'm not going to fight with it to renumber. So let's just do it ourselves. So if we now have a look at question 5, what we have new here is a fraction. Okay, so there's a question. I need to go back here. Okay, so Sipilele, please remember that I've just showed you how to do this on your calculator. If you take the cube root of 64, which is what we needed to do in order to find, or in order to do the inverse, you get 4. Now, if we think about why that answer is true, 4 times 4 times 4 gives us 64. Why? Well, 4 times 4 is 16, and 16 times the second 4 gives us 64. So that is how I know that the cube root of 64 is 4, because 3 4s multiplied together gives us that value underneath the cube root. Okay, so exactly as Yolanda said there, Morgan, cube roots are a bit different. We only divide when there's a coefficient, so when there's multiplication, because that's the opposite of, so division and multiplication go hand in hand. If there's an exponent or power, as Yolanda said, that is when we need to use roots and exponents. Okay, Pretty, we're going to try this one more time. If not, please put your question in the chat. There should be a pop-up to unmute. There we go.
What's the point of the square root?
So there isn't a square root in the question. If you're talking about the dark green square root, I was just explaining what the inverse of a square root is. If you're talking about the cube root in the question, so this root over here, the point of it is to get rid of that exponent of 3. If I want to get rid of an exponent, so I have to use the opposite operation, I have to then introduce a root. And in this case, because my exponent was 3, I had to use a cube root. Does that make sense?
Yes.
Cool. Well done. All right, guys, so if we go back to this question 5, we now, like I say, what we have new here is the fact that we've got a fraction. Doesn't change anything, still need to use inverse operations, but we have a fraction. Now, we've done this before, so I would like you guys to try this question for me. Please put your answers in the chat, and then I'll give you a few minutes, and then we will go through it together. Sipilele, Morgan, Pretty, absolute pleasure. And guys, remember, keep putting your questions on the chat, and Yolanda and myself will both help you when we see them. So grade 8, what you're doing now is you are trying this question 5. 3x divided by 4 plus 5 is equal to 2. Once you have an answer, please remember to check it through substitution. We've spoken about how to check our answers. So whenever you get an answer for an equation, do make sure you check. I'll give you a few minutes, but again, I want your answers on the chat, please. Remember all of your inverse operations. So think about what the opposite of addition is, what the opposite of division is, and what the opposite of multiplication is. And through using all of that, you will be able to solve your equation. Morgan, I'm assuming because you would like to screenshot question 4, so I will do that so that everyone can still see it. Remember, guys, we're solving an equation, so it should be x equals and then some value that we have. In grade 8, remember when we do go through it, please make sure you mark your work, regardless of whether you got it correct or incorrect. Do you need to mark? And remember, check your answer. So once you have an answer, substitute it back into your original equation. So replace x with your answer and make sure that your left-hand side equals your right-hand side. That's how we check. Guys, you can't have options of answers here. There's one answer and one answer only. Give everyone another minute and then we will have a look. Answers I'm seeing so far look good. Some of you do need to check and make sure you mark when we go through it. But again, I've told you to check your answers, so you should be seeing whether or not your answer is correct or not. Alrighty, guys, let's have a look. So again, please mark your answers as I go through it. Please make sure that you can identify where your mistakes are, if you've made any. And please remember that you can put any questions you might have on the chat as I go along. But let's make sure that we are checking our work. Okay, so we've got our equation 3x divided by 4 plus 5 is equal to 2. And my goal, remember, guys, is to get that x alone. So I need to get rid of the plus 5, the divide by 4, and the 3x. So there are 3 operations that I need to use inverses of in order to solve for x. Now, remember I said to you, I want to say on Monday, but in a lesson, probably in most of our lessons, I've said to you, what we try and deal with first is the value that we're adding or subtracting. So what that means is I first want to deal with this plus 5. I wanted to join the 2. Now, in order for that to happen, inverse operations. So that means my 3x over 4 is going to stay 3x over 4 for now. But now this 5 is joining the 2 on the right-hand side, and so it becomes negative 5. So what I have is 3x divided by 4 is equal to negative 3. 2 minus 5, negative 3. The next thing I now want to deal with is I want to deal with this denominator of 4. Now remember, the denominator of 4 means we are dividing by 4. And again, I then need to use inverse operations. The opposite or the inverse of division is multiplication. So I'm going to divide the left-hand side by 4 to essentially get rid of that 4. But remember, if we do it on one side of our equation, we have to do it on the other side of our equation. And so what we now have on the left is just 3x is equal to negative 3 times 4. Now we know that a negative times a positive is a negative, and 3 times 4 is 12. And so what we have here is negative 12. The final thing I need to now do in order to solve for x is I need to get rid of my coefficient. So because it is 3 times x, so it's a multiplication, I need to do the opposite, which is to divide to get x alone. But again, if I do it on the left, I have to do it on the right. And so what we now have is that x, just do that, x is equal to negative 12 divided by 3. A negative divided by a positive is a negative, and 12 divided by 3 is 4. So our answer here for x is -4. Please focus. If we just want to do a quick check of what we've done, remember, check involves substitution. And what we're doing is we're wanting to make sure that the left-hand side is equal to the right-hand side. We've got 3 times -4 divided by 4 plus 5 should be equal to 2. So let's check. 3 times -4 gives us -12 in our numerator, divided by 4 plus 5 equals 2. -12 divided by +4 is -3 plus 5 should be equal to 2. And -3 plus 5 is +2. And because 2 is equal to 2, I know that my answer is correct. So again, grade 8, this is why we need to check our answers. If you are not getting that the left is equal to the right, then you should know that you are not or have not gotten the correct answer. All right, so Morgan, just tell me from where you want to re-explain it. So if this is step 1, 2, 3, and so on, from which step do you need re-explaining? Just that I know exactly where we need help. And again, guys, what you're doing is you are, cool, I'll do it now. What you're doing is you're taking screenshots. I'm going to explain from step 2. So remember, step 2, I've got 3x divided by 4. So this division by 4, I don't want a fraction. I want to get rid of the division by 4. The inverse or the opposite of division is to multiply. If I multiply the fraction by 4, I get rid of it. If we just have a look at that on the side, like in terms of actually mathematically working it out, we would have 3x over 4 times 4, which we know could be written as 4 over 1. 3x times 4 is 12x. 4 times 1 is 4. And if we simplify 12 divided by 4, we end up with just 3x, no fraction. So that's why I've got a 3x there. And then just remember, whatever you do to the left-hand side, you have to do to the right-hand side. Cool. Amanda, how did we end up timesing? So Lindo, I'm assuming this will answer your exact same question. No, Amanda, I haven't multiplied 3 by 2 anyways, so please just double check that. I haven't multiplied 3 by 2 anywhere, so just double check that. Lindo, I've just explained it. So it was in response to Morgan's question. I've just explained why we times it so that we no longer have a fraction. Right, guys, so I hope you've all taken screenshots.